Next topic, resultant of system of forces. As usual, let's have an introduction. Okay. So the effect of a system of forces, what we discussed previously, on a body is expressed in terms of a resultant. Okay. So other definitions of resultant are, first, it is a single force obtained by combining a system of forces acting on a body, or rigid body to be exact, and it also determines the motion of the body. To give a better explanation, or to illustrate, let me show you. Let's say we have a concurrent force system. So concurrent force system, let's say we have these forces. Okay. To get the resultant, a resultant is just a single force that has the same effect of all of these forces. Okay. So let's say that resultant is this. Okay. So let's call this F1, F2, F3, F4. The total effect, or the combined force of all of these, is just equal to the single force R. That's the resultant. Another thing about resultant is, if you apply this force on a body, okay, that means the total direction, or the final direction of your body, will be downwards to the left. Since again, the resultant also indicates the motion of your body. Okay, so that is what a resultant is. Next, talk about forces and their components. You already know the definition. Now let's talk about its parts. Okay. First, we have this scenario. We have a force. We're given its angle from the x-axis. Components for a force are its x and y components. So to get x component, we call that f of x. The equation is f cosine theta x, where theta x is theta, or angle from the x-axis. Take note of that, okay? This equation is only applicable for angle, or theta, taken from the x-axis. Now, in the same manner, we have Fy, which is the y component of your force F. Equation for that is F sine theta x again. Now, in the event, for example, we're given the components of your force and we want to know the total force, this is the equation. F is equal to square root of fx squared plus fy squared. And to get the angle from the x-axis, that's just tangent theta x equals Fy over x, f of x. Now let's derive those equations. How did those equations came to be? Okay. So components of a force. Once again, we have let's say we have this Cartesian plane x and y, right? And then we have a single force F. And we're also given angle from the x-axis. So f of x is just the f, or force component of a force along the x-axis. To solve for that, we have this. This is your f of x. And then Fy is just a force along the y-axis. That's your y component. So this is your Fy. So to solve for that, look here, right? If I draw a straight line here, what we see is a right triangle. And we have equations for right triangles, right? Specifically, trigonometric equations. So looking here, if I want to solve for f of x is just actually the base of my right triangle. And then f is the hypotenuse of my right triangle. If I'm given theta and hypotenuse f, what equation can I use to solve for f of x? Can anybody give me? What equation, trigonometric equation, should I use to get the base of a right triangle given hypotenuse and an angle. One. We have three trigonometric functions, one for sine, cosine, and tangent. Correct. I encourage you to type in your answer so that it's easier to see who got the first answer, okay? So correct, it's cosine. So correct, Naomi and Marilyn. So Peliosis and Vinyoso. Okay, cosine. So recall, SOHCAHTOA, right? So cosine theta is adjacent over hypotenuse. So therefore, relating that to our figure, cosine theta is adjacent here is f of x, and our hypotenuse is f. And then from this, we can say f of x is just f cosine theta. Okay, very good. Okay, yeah. Thank you. Once again, I encourage you guys to type in the chat because it's easier for me to record who got the point. Next, how about f of y? So in this case, yes, correct. Gian and Lauren. So f of y is also equal to this part, which is the leg of your right triangle. Okay, so we're gonna use again one of your trigo functions, which you're correct, it's sine. So correct Gian and Lauren, so Bustos and Chua. J Lau. Okay, so sine. So sine theta, opposite over hypotenuse, right? The original equation. Relating it to our figure, sine theta, opposite is this, which is equal to f of y. So that's fy over hypotenuse, which is f. Therefore, f of y is just f sine theta. Okay? And that is how we got those equations. Next, what if we got f of x and f of y? How do we solve for f? Once again, we're going to use equation from your right triangle. You're not given theta, all you're given is f of x and f of y. How do we solve for f? What theorem will we use for right triangles? Very good, Michelle and Colin. Leon and Perry. Perry. Correct, it's Pythagorean. Pythagorean. Okay. If you have A, B, C, AB being its legs, C being the hypotenuse, our Pythagorean theorem is A squared plus B squared equals C squared. Relating that again to our figure, that is fx squared plus fy squared equals f squared. Therefore, f is just square root of fx squared plus fy squared. Now we got f. What if we also want to solve for theta? Again, what equation should we use? We only have f of x and f of y to solve for theta. Correct? Nicolas and Lauren. So Buena and Chua. It's tangent. Oh. Nicolas Buena. Okay, you're not in my class list. Right. Okay. Right. Yeah. It's fine. Okay. So yes, it's tangent. So tangent, again from Sokotoa, opposite over adjacent. Relating that to our figure, tangent theta is opposite is Fy, adjacent is Fx. Okay, so that's our equation, or if you want to solve for theta itself, that's arctangent or inverse tangent Fy over Fx. There. Okay, so that is how these equations were taken. Now, what if we're not given an angle? Instead, we're given slope. So what we're going to do about that? So here we have this slope. Rise, run. So rise is V, run is H, V for vertical, H for horizontal. And then we call the hypotenuse of that, or the slope, as R. Our equation for that, f of x is equal to f times h over r. Fy is just f times v over r. And then r itself, the slope is just square root of h squared plus v squared. So how do we get those equations? Once again, let's find out. Okay. Just gonna make this smaller, okay? Right. Oh, I can put this here. Okay. Anyway, let's have another Cartesian thing. And this is your x, y-axis. We're given a force F, but instead of given an angle, we're given slope. So again, this is h, this is v, this is r. To solve for r, that's easy. We're just using Pythagorean theorem again. So r squared equals h squared plus v squared. Therefore, r is just square root of h squared plus v squared. Okay. Now, how do we get fx and fy? Fx and fy are these points. So again, this is your fx, and then this is your fy. This is orange. Okay. So in the same manner, we're gonna extend. We're gonna extend this line, right? When you have another right angle, and actually, sorry, right triangle. And actually, you also have two right triangles. This is your smaller right triangle. This is your larger right triangle. They have the same slope, the same hypotenuse, right? Therefore, we can say they are similar triangles. Similar triangles, and when we have similar triangles, we can use ratio and proportion to figure out the value of the legs or parts or sides of each triangle, right? Therefore, once again, by ratio and proportion, by R ratio proportion, call the equation for that is the ratio of the sides of one triangle equals the ratio of the sides of the other triangle. So let's say, looking at the smaller triangle, okay? All right. Hypotenuse over base. So R over H is equal to hypotenuse over base of the larger right triangle. So hypotenuse is this, which is again f, right? That's f, f over base is f of x. Therefore, solving for f of x, that's just f times h over r. Okay, let me move. And moving things around, multiplying both sides by f of x, multiplying by h, and then dividing by r. You're left with f of x equals f times h over. Okay? In the same way, now let's take height over, or rather hypotenuse over height. Okay? So r over b equals, so r again, that's just our hypotenuse f. And then b, height, this is the corresponding side, your f of y. Okay? Moving things around to solve for f of y. Okay? That's just f times b over. That is how you got these equations. Okay? Okay. Any questions so far? Please answer in the chat. Okay, great. Let's move on to the next topic. Okay. So that's components of a force. Now, how do we get the resultant? Let's start with the resultant of a concurrent force system or resultant of concurrent forces. So once again, concurrent forces, when they intersect at a common point. So this is an example. So to get the resultant, first, we already know how to get the components, right? So we're just going to take the summation of all of its components first. So for example, here, we have Rx. Rx is just a summation of all of your x components of each force. So that's why it's a summation of f of x. In the same way, we have Ry, which is again just a summation of all of your components y. Summation of f of y. Once you solve for Rx and Ry, you've gotten the total x component and total y component of the forces of the entire system. So we're just going to use Pythagorean theorem now to solve for R. Therefore, R is just square root of Rx squared plus Ry squared. In the same manner, we're going to use tangent. Tangent theta equals opposite over adjacent. Opposite is your y component, adjacent is your x component. Hence, we have these equations. Okay? So that's it. That's how we're going to solve. Now, if we take summation, okay, that's algebraic summation, meaning there's a positive and negative force. To figure out what is positive and negative, we have these sign conventions. First of all, upward to the right is positive. So upward, left, to the right, positive. If your forces are downward to the left, so downward to the left, those are negative forces. Okay, so apply these sign conventions when creating equations so that we have correct answer. Okay, so let's try it. Let's start with examples. Once again, remember your sign conventions, okay? Upwards to the right, positive, downwards to the left, negative. Let's start. Number one, determine the x and y components of the forces shown. We're just concerned with components. We're not asked to do resultant. So that's easy enough. X and y components. Let's try it. Okay. So first step, look at your system. All of my angles are from the x-axis. Therefore, I can use the equation that was given to us. Okay, your fx is cosine, fy is sine. Another thing, I'm given slope. I'm not given r, so that's the first step. I need to solve for r. Okay, so r is just square root of the side. So 5 squared plus 12 squared. Solving for that, we get 13. So I'll answer first. Okay, so you just have to listen for now. Later on, I'll ask you guys to compute. So once again, you can just listen for now. Once again, that's 13. Therefore, you can write 13 here. Okay. First step, take the summation of your components. You can start with either, choose whether you want to start with x or y. Again, we're not taking resultant, we're getting component. Okay. So for me, usually I'd like to start with x. Okay, so let's start each force. We'll work on each force. Let's start with F1. So F1x to denote that it's x component. So solving for that, recall our equation, F1x is F cosine theta, right? First of all, you're gonna choose whether or determine whether it's positive or negative. F1 is to the right, therefore positive, so positive F cosine theta. Wherein F is 58, that's 58 cosine 30. Make sure your calculator is in degrees. Solving for that, we get 50.23. And then unit, look at the units, they're in kilonewton. So this is kilonewton. Don't forget the unit. So that's our first answer. Next, let's move on to F2x. Once again, determine positive or negative. It's to the left, therefore that's negative. Force is 50. And then cosine angle is 45. Solving for that, we get negative 35.36 kilonewton. So that's your second answer. Do the same thing, F3x. F3, we're not given angle, we're given slope. So once again, determine positive or negative. It's to the left, therefore, once again, negative. And then our equation is F, which is 45. And then depending on what we're looking for the x component, so the horizontal. One trick you can use so that you don't have to go back to the equation is just checking which leg is also horizontal. Okay, we're looking for x, therefore we need to find the leg that is also along the x-axis, which is this leg. So that's 5. So times 5 over, and just look at the hypotenuse, that's 13. Once again, so that you don't have to go back to your equations, to get the equation for this, write out your force multiplied by, depending on what component you're looking for. I'm looking for the x component or horizontal component. Therefore, you just have to look for the horizontal leg, which is this. Horizontal leg, vertical leg. That's 5 over hypotenuse 13. Solving for that, we get negative 17.31. Once again, unit was kilonewton. And then lastly, F4. F4x is to the right, therefore positive. And it's not at an angle. It's directly to the right, therefore that's just 40. So 40 kilonewton. And that's how you get the x components of your force. Now let's move on to the y components. For this, okay, I'll ask you, can anybody give me the equation for F1y? Equation for F1y. Very good. It is 58 sine 30. Correct, Rain and Marilyn, Chero, and Eleosis. Okay. Simon. And then Len. Okay. 58 sine. Positive because it's upwards. Please solve. What's the answer? What's 58 sine 30? Correct, it's 29. Correct, Rafaela and JM. Joaquin. Again, make sure your equation or calculators are in degrees. So, pangalangan and illustrate. Okay. 29. Next, F2y. What's the equation for F2y? Okay. Correct, Naomi and Gian. Negative. Nope. Okay, once again. Nope. Trisha, correct. And Jomar. It's positive 50 sine 30. Okay. So that's Palomares and you. Okay. Palomares. You. Yep. Positive 50 sine 30. Why? It's also upward. Okay. Remember, for x component, it's either left or right. Vertical component or y component, upwards or downwards. Upward positive, downward negative. This is upward, therefore positive. 50 sine 45. And what's the answer here? Please compute. Correct, it's 35.36. Give me the decimal form. Correct, Trisha and Matthew. So, Tanilon and Palomares. Okay. Late enrollee, not here. Okay. And then F. Okay. Next, what's the equation for F3y? Very good. Correct, Gian and Gian. Bustos and Bonquit. It's 45 times 12 over 13. Dalawang Gian. Yes, and it's negative. Negative because it's downward. Negative, the force is 45. We're looking for vertical component, so let's look at the vertical leg. That's 12 over hypotenuse 13. What's the answer? Correct, Naomi and Jomar. Okay. And Jude, Jomar, you. Negative 41.54 kilonewton. And lastly, F4y. Can anybody give me what's that? Very good. Zaira and Nicolas. It's 0. So Luis and Buena. Mm-hmm. Okay, Ortiz. Okay, 0. Why? There's no y component to this since it's just to the right. So that's just 0. And that is how you take the components of a force. Any questions so far? Any questions for number 1? Please answer in the chat. Okay, great. Let's move on now to number 2. Triangular block shown in the figure is subjected to the loads P equals 1,600 pounds and F equals 600 pounds. If AB is 8 inches and BC is 6 inches, resolve each load into components normal and tangential to AC. So we just have to resolve into other components. So how do we do that? Number 2. So once again, basically, the question was asking us to resolve P and F into normal and tangential to AC. This is your AC. Normal just means perpendicular. Tangential just means having the same slope. Okay. If I extend this line, your P, this would be perpendicular to that, and that would be your PN. And then tangential would just be at the same line. This would be your PP for tangential. Okay. Now instead of drawing it that way, I'll place it here instead. Okay. This is now my this is PP, PN for normal. And then tangential just has the same slope, so just follow the slope as much as possible. This is our PP. Okay. Now to make our drawing more accurate, make sure it creates a right triangle with your force, wherein your force is the hypotenuse. So to draw that, we can do it this way. Make parallel lines again. So this is your PP for tangential. Okay. And then let's create another parallel line here to this. This is your PN. If you want to make an accurate drawing of its components. Let's do the same for your F. Okay, let's try. Once again, normal is perpendicular to AC. So drawing that, we have this. Right? And then tangential has the same slope. So try to draw it with the same slope. And this is your PP. And once again, if you want an accurate drawing, draw perpendicular parallel lines. You have that. Okay, this is your FP. Then do the same thing here. This is your Fn. Okay, now we have drawn the components. Next step, how do we draw equation for each component? Okay, so we're not given angles, we're given dimensions. So let's write the dimensions. Let's see what it was. AB is 8, BC is 6. Okay, that's it. AB 8, BC 6. This is your 8. This is your 6. And from that, I can create a slope here, right? Or you can just take this whole entire thing as your slope and just solve for the hypotenuse. Solving for the hypotenuse, that's just r equals square root of 6 squared plus 8 squared. The answer to that is 10. Therefore, this is 10. Now I have a slope or dimensions of this right triangle. So what is the importance of that? Well, we're gonna transfer this into our drawing. Okay, so to do that, recall your alternate perpendicular angles theorem. What does that mean? If we have two perpendicular angles, that means the ratio of their sides are also equal. So to illustrate, let's say, okay, let's take this. Let's take this. Let's take this angle, right? And let's figure out what lines or what angle is perpendicular to that. Okay. To look at it. Again, we're taking this angle. Perpendicular to this side is this line, right? And then perpendicular to this side is this line, since that is normal to this. Okay? We have two perpendicular angles, okay, and their dimensions or ratio of their dimensions should be equal. In short, what is in front of this angle? 6. Therefore, what is in front of this should also be 6. So this is also 6. Okay, so that's how you solve for that. And then now that I know this is 6, therefore the other leg is 8. This is 8. I can create the slope of this force in relation to this triangle. Okay, once again, this leg perpendicular to this leg perpendicular to this leg. Opposite of that angle is 6. Therefore, opposite of this should also be 6. So now I have a 6 here. Okay, let me just delete all of that. Once again, this is 6. Or you can draw it this way. Get the slope. This should be 6. And then this is your 8. And then this is your 10. The hypotenuse. So now you have the slope of this. You can get Pn and Pp respectively, just by using your similar triangles theorem. Next, do the same for F. Once again, let's look for perpendicular angles. Okay, let's have this and this. Okay, perpendicular to this side is this line. Perpendicular to this side is this line, right? Since this is normal to that. Therefore, angle opposite here is 8. Therefore, whatever opposite here, this should also be 8. So now we know this is 8. So let me delete that again. This is 8, or we can draw it this way. The slope now of this line in relation to this, okay, this is 8. This is 8. Therefore, the other leg now is 6. And then this is your 10. Yeah. So now we have the slope of your forces. Now we can create an equation out of those. Let's start. Start with P. Okay, Pn. Just recall our equation earlier, right? Pn, or in our previous example, to get F3x, just get the leg that is also along the horizontal. So that just means get the leg that is parallel to your component in question. In this case, this is Pn. Leg that is parallel to that is this, so that's 8. So we're getting 8. So take the total value, that's 1,600, okay, times 8 over hypotenuse. Our hypotenuse is 10. Please solve. What's the answer here? Correct, Lawrence and Joaquin. So Gozo and Illustre. Gozo. It's 1280. So 1280 unit pounds. And then if we're asked for direction, just draw your arrow. So PN is this way. You can just do it that. Okay. Our first answer. Now let's do the same for PT. So PT, again, just copy the total force, 1,600. This is PT. Angle parallel to the leg or side parallel to that is this. So that's 6. So times 6 over hypotenuse 10. Please compute. What's the answer? Correct, Francisco and Rafaela. So legado and pangalanan. Legs. Okay, 960. 960. Unit pounds, direction. You can just follow that direction as an arrow. Then you have that. Okay, so that's our answer for PN. Let's do the same thing for F. Start with Fn. Knowing how to do Pn, can anybody give me the equation for Fn? Very good. Correct, Francisco and Rafaela. Legado. Legado. We already have 2 points. Those who have 2 points, avoid chatting for now. Okay, so let's give it to Emma, Joseph. So it's 600 times 6 over 10. Very good. So Fn, again, just copy the total for 600. This is your Fn. Parallel to that is this, which is 6, if you can see. It's 6. So times 6 over hypotenuse 10. Di pa ako nagtatanong. Ba't may sagot na kayo? What's the answer here? Correct, Andrew and Ryan. So, Aylan and Kito. Wait for me to ask. It's okay. So correct, it's 360. Once again, direction downward. That's our answer. Next, lastly, can anybody give me the equation for FT? Correct, Colin and Gian. So Pere and Pere. Pere? 600 times 8 over 10. So once again, copy total force times. This is FT. Parallel to that is this leg. So that's just 8 over hypotenuse 10. Please solve. What's the answer? Correct, Ridley and John. And La Cruz and Sosa. Okay. And then oh, late enrollee. uh, Okay, so yeah, it's 480. 480 pounds, and then follow the direction. Okay, so that's how you solve or resolve forces into other components. Any questions for number 2? Please answer in the chat. Okay, great. By the way, for questions, you can use your mic so that you don't have to type it if it's too long. Okay. All right. No questions for 2. Let's move on to number 3. The body on the 30-degree incline in the figure is acted upon by a force P inclined at 20 degrees to the horizontal. If P is resolved into components parallel and perpendicular to incline, and the value of the parallel component is 1,800 newtons, compute the value of the perpendicular component and that of P. So we have this figure. We're given your degrees, your angles. We also have another given. Value of the parallel component is 1,800 newtons. Okay, so basically we're solving for P and the perpendicular component. So let's start. P and perpendicular component. So that's number 3. So again, let's write out our given the parallel force. Okay, so we can type it like this. So this symbol means parallel. This symbol means perpendicular. Okay, for those who don't know yet. So parallel, again, it was given 1,800 is the unit newton. Let's double check. 1,800 newtons. Okay. So now we're looking for this P and component perpendicular. So let's try to draw that again for us to clearly see the relationship between our values. So parallel to the incline, this is our incline. So just draw a parallel line. Just this. I think that's fine. Yep. So this is your parallel. P parallel. Perpendicular is this, right? However, for our drawing to be more accurate, just draw parallel lines. So parallel. Yeah. So our P perpendicular is just up to here. By the way, my components or your components should have the same direction of the force itself. For example, here, this is downwards to the right. So this is also downwards to the right. This is also to the right. Okay? You're not supposed to draw it this way because that is the opposite direction of your actual force. So just make sure they're consistent. And then for the parallel component, once again, just draw a perpendicular line, a parallel line. Okay. So now we have this. We know this is 20. Okay. Next step is to figure out what is the importance of this 30. Now, if you look closely at our drawing, this is the importance of drawing your figure correctly. Okay. If I extend this line, okay, if I extend this line, we have alternating interior angles. And recall your alternate interior angle theorem from your previous math classes. According to alternate interior angle theorem, okay, these two angles should be the same. So this is 30, therefore this is also 30. Okay, and since this and this are parallel, therefore this is also 30. Okay, okay. Once again, alternate interior angle. This is 30, therefore this the alternate interior angle is also 30. These two are parallel lines, so therefore this is equal to this angle, so that's also 30. Okay, now I know this total angle is 50. I can redraw it just so that you can see it clearer. Okay. This is your PL, this is your PP, sorry, P parallel, P perpendicular. Okay, and then we have this angle. This is for P. This is P. And we're given an angle here. Okay, 20 plus 30. This total angle therefore is 50. Therefore, this is 50. Okay? And now I have this figure. I can now solve for what's being asked, which is the value of this and this. And recall again, this is equal to 1,800 newtons. Let's start with let's start with the equation for P. I'm going to use the parallel to solve for P. Okay, how do I do that? Again, recall your trigonometric functions. I have an angle here. This is P parallel, and that is equal to this side. So essentially, I have an angle and adjacent side of this right triangle. You have a right triangle. Okay. So I can use the cosine function. Okay, cosine theta equals adjacent over hypotenuse. Relating that to this figure, cosine or theta is 50. Adjacent is this, which is also equal to your parallel. The opposite sides are equal. So that's P parallel over hypotenuse P. We have the value for P parallel. So finally, we have cosine 50 equals 1,800 over P. So please solve what is P. Okay? Correct, Rafael? The only one to answer? Kaboom. It's 2,800.30. Too late. 2,800.30 unit is Newton. So to solve for P, that's just P equals 1,800 over cosine 50. Just plug this into your calculator. You should get 2,800.30. Okay, let me double check. Yep. Right. Now that we have P, we can solve for P perpendicular. Once again, using the same concept, your trigo functions. Okay. So can anybody give me the equation for P perpendicular now? Okay, so this is your perpendicular. We now have solved for P. We have an angle. Good. Okay. Correct, Zyra. And Okay. Who is that correct? Ba talaga? Okay, only Zaira got it correct. Yep. So we have two ways to solve for this. Let me just okay. For this, for this, and then no one got the other way. One way is to use tangent. Okay, so you already know this. We know the angle. Okay, so to solve for this, we can just use tangent. So tangent theta equals opposite over adjacent. Once again, our theta is 50. Opposite is what we're looking for. P perpendicular over adjacent given 1,800. Okay. From this, please solve what is P perpendicular. Okay, very good, Michelle and Zaira, since and Rain and Simon. Okay. So Michelle, you already got 2 points. So leave it. I think Zaira also had 2 points. So Rain, okay, 2. Since no one else answered, give it to Michelle. Okay, so it's 2145.16. By the way, if you want to get an accurate answer, you can try storing this into your calculator. And then use that value that you stored if ever you're going to use the value of p. Here we don't have to since 1,800 is given. But in case we use this, try to store this. That's our answer, Newton. Now another way to solve for this is using sine. Now, so sine theta equals opposite over hypotenuse. So that's sine 50 equals what's opposite? P perpendicular over hypotenuse P. Okay, therefore, this is where you use your stored value for P here. Okay, therefore, solving for P perpendicular, you should also get 2145.16. So that's two ways. This would be the more accurate answer because you're using the given 1,800. Here, you're using what you solved for. If this is incorrect, therefore your answer here will also be incorrect. Okay? So take note of that. As much as possible, try to use the given values. Okay? So that is number 3. Any questions for number 3? Please answer in the chat.
Ma'am,
Yes?
when drawing the parallel component po, lagi po siyang in respect to something else sa system?
Yes. You mean
Okay.
these?
Opo.
Yeah. This is parallel to the opposite forces. This is parallel to this.
Okay. Thank you po.
Okay. Now you don't have to do this. This is just to show you a more accurate drawing. You can just do it this way. If you're used to solving, you can just denote this as parallel and perpendicular. Okay. Now I'm doing it that way to show you that this turns into a right triangle. That's why, and that's how you'll get this drawing.
Hindi po interchangeable yung parallel and perpendicular component po.
And then you
Okay.
can. Okay. So that's the reason why this is important. You cannot interchange tangential and normal. Okay, this is also always your tangential component to this. Since this force is the one that has the same slope as this, Pn normal, this force is the one that is perpendicular to this slope. Okay. So you cannot interchange them in the same way you can't interchange these two. This force is parallel to this slope. That is what we're looking for in the problem. Component of a force that is parallel to your slope. And then this force is the component that is perpendicular to the slope. Okay, so you cannot interchange them. Okay. Any other questions?
Wala na po. Thank you, ma'am.
Okay, thank you. All right. So I'll end the discussion there since it's almost time. You can try to solve the following problems on your own as practice or not. Depends on you. So next meeting, for those who are absent last meeting, we'll have a diagnostic exam on Saturday. Okay. For more details, you may check our. You can watch our orientation here in your Zoom. You can also read our PDF file. As you can see, our lectures are already uploaded. Okay, but to summarize, diagnostic exam on Saturday, open camera. Okay, you must attend the Zoom meeting. No video, zero. Okay, you don't have to upload solution for your diagnostic exam. Just answer the diagnostic exam, and then it's only until it's from 12 to 1:30 only. I think that's it. Yeah. Yes. Coverage of your diagnostic exam would be physics topics. As you can see, we've used physics concepts, vectors, some math-related concepts. Those will be the topics for your diagnostic exam. Okay. All right. No more concerns, right?
Ma'am,
Yes.
question po.
Yes.
About lang po sa course expectation po na ipapasa. Word
Yes.
file po siya namin ipapas po.
Oo.
I-PDF po namin or okay lang po na naka-document po?
Yeah. Kung plain, walang design, you can just submit it as Word file.
Okay po, thank you po.
Okay, thank you. For those who are late, yeah, I got my class list at the first day of our meeting, first meeting. That's why your name is not, if you're a late enrollee, your name is not on my list. I'm going to update it next time. So don't worry. I'm just going to update my list. Any other questions, concerns before I dismiss you? Okay. Once again, prepare for diagnostic exam on Saturday. Topics, physics, and some math concepts. All right. Since you don't have any more questions, you may go. See you next meeting. Goodbye, class.
Bye po, ma'am. Thank you po.
Thank you po.
Thank you po.
Thank you po, ma'am.
Thank you po.
Thank you po.
Thank you po.